Our topic for today is called Midpoint of Segments. Everybody take a highlighter right now, and I want you to highlight the topic for today. So midpoint of segments. We're going to do a better job of realizing what each of our notes are going to teach us about so that when we're looking back through our notes for help, we know what we're looking for. So today, we're going to look for midpoint. Now, midpoint is a formula on your nice yellow formula charts that we have. Look for the word midpoint on the formula chart. What number is it? 16. Amazing. So today we're going to learn about number 16 formula on that formula chart. Midpoint is exactly what it sounds like. The midpoint is a point that divides a segment into two equal segments. That is a midpoint. And midpoint sounds like middle point. That's literally what it is. It is the middle point between two other coordinate points. Now, on a number line, again, really easy to find the midpoint because you just count them up and find the middle. But when you count things up and find the middle, that's technically taking the average. So the other idea we can think about, if it helps connect it to something, the midpoint, especially on a single number line, is like the average. When you average stuff together, you add them up and divide by the number of things you added. You're always adding 2 for midpoint. So midpoint formula is we add them up, divide by 2. That's going to be the midpoint. It's really as simple as it is. Okay, so we're going to find the midpoint of AD. First of all, let's talk about what AD looks like. We're going to highlight a bunch on here, so if you highlight with me, just do it in 3 colors. AD is from A to D. What is the value of A? What number is A on? -1. So my midpoint formula says we start at -1, and then we add what number? 7. So we're going to do that, and we're going to divide by 2 because we're going to average them together to find the midpoint. -1 plus 7 is 6. 6 divided by 2 is 3. Now, this makes sense because if we look at 3, isn't the number 3 in the middle of points A and D? It is 1, 2, 3, 4 away from A and 1, 2, 3, 4 away from D. It is smack dab in the middle. That's called the midpoint. Don't overthink these. It's just the middle. Does that make sense? But what we learn about the midpoint, if M, the midpoint, is equal to 3, then we know that the points A to M, line segments, is equal to M to D. Because it's in the middle, it creates 2 equal or congruent line segments since we're splitting it in the middle. Can you try one for me? Find the midpoint of AC. So this time we're going to start at A and go to C. Can you do the same sort of work to find the midpoint of C? Of AC, sorry. Midpoint of AC. If I were doing this problem, I would say that the midpoint between AC is A, which is -1, plus C, which is 4, divided by 2. -1 plus 4 is 3, and I get 3 divided by 2, which 3 over 2 is the perfect fraction. I love that answer, but I know on a number line that doesn't really mean anything to you guys. So if we put that in our calculator, it's 1.5. Is that what you got? Yeah. Great, so my midpoint is 1.5, or 3 over 2, which means about right here, that is halfway between A and C. It's the midpoint. But what it also tells us, since it's the midpoint, is that we have created equal segments on either side. AM is going to be equal to MC. So they are congruent line segments since their lengths are equal, since we stopped at their middle point. Now that's fine and dandy, but that's on a single number line. And in geometry, we're not always going to have things on a single number line. We're going to have them on a coordinate grid. So if we were trying to apply this idea of average or halfway point to a coordinate grid, on a coordinate grid, if I were trying to find the distance between x1 and y1 and x2 and y2, I wouldn't just find one number, I would find 2, a coordinate. So this formula, if you want to color code along with me, is straight up a coordinate where you take the average of the x's. x1 plus x2 divided by 2. That's your new x value, comma. y1 plus y2 divided by 2. That's your output value. That's your y. So we just have to find both of those terms, and it creates a new coordinate point for us right in the middle on that line segment. This is now my midpoint M. It's still a coordinate point, not a single number, so don't answer me with one number anymore. When they're on a coordinate grid, I need 2 because I need a location. Okay? But it is still just the average of the 2 points. We just have to do that problem twice. First, average the x's, then average the y's. Let's write that down for ourselves. So we average x's, and then we average y's. That's the midpoint. It's going to be extra important that you label things correctly for the midpoint formula. Just like we did with the distance formula, we want to make sure we put the same things in the right spot. So if we are finding the midpoint for problem number 3, we have the endpoints R, and we have the endpoints S. We need to find out the midpoint between them. So I'm going to label, and I'm going to label correctly. This is x1 and y1. Remember, coordinates always come with an x and a y value. And this one is going to be labeled x2, y2. So if I wanted to find the midpoint, I just need to average my stuff together, meaning the midpoint is going to be equal to x1, which is 1, plus x2, which is 4, all divided by 2, an average, comma. y1 plus y2, all divided by 2. We're going to leave our answers, or we're going to write our answers as both fractions and decimals. I prefer fractions, but I realize that you prefer decimals, so we're going to do both. If we do 1 plus 4, what is 1 plus 4? 5. So the first one would be 5 over 2, comma. What is negative 3 plus 2? I just totally said the answer. Negative 1. That is our answer for our midpoint as a fraction. But I know if I then asked you to plot this point, you'd be like, I don't know where 5 over 2 is. I get it. We're uncomfortable with fractions. We'll get better. If we change those to decimals, this is 2.2. Wait, no, 2.5. Comma, negative 0.5. I prefer fractions, but so long as it's a pretty decimal, you can put it as a decimal. So like 0.5, 0.2, 0.7, those are fine. But 8, 3, 4, 5, 6, 7, 8 being your decimal, don't love that. Let's leave that one as a fraction. Can we try one on our own? Great, number 4 is yours. I'll let you think for a second, and then I'll start giving hints if you're stuck. So give yourself a second to think. Here comes the hint if you need it. Once my formula is ready, we would have 10 in the first spot. What goes in the second spot? Negative 5. And now the top of the y's? 7. And then? Negative 3. Cool. Beep, beep, beep. We type it in on our calculator. Make sure we're computing correctly. This should be 5 over 2, comma 2. If we change that to a decimal, because again, I know you like to think in decimals, that would be 2.5, comma 2. That's the coordinates we would plot for the midpoint between the 2 points. How do we feel about that? Good. Can I make it a little challenging? Please? I'm going to do it anyways, though. Sorry. Okay. Here's the problem. It says the midpoint of the line segment XY is 2, 1. One endpoint is 1, 4. Find the coordinates of the other endpoint. Okay, I find it helpful to draw a picture. So here we have a line segment. We'll call this line segment X, Y, and we know in the middle is the midpoint. Now, because it's in the middle, it creates 2 congruent segments. So I'm going to put these little tick marks on here to talk about them being congruent. Remember, we sort of discussed that last class that a single tick mark or a double tick mark indicates that the 2 line segments are equal or congruent. We also then know that this coordinate is 1, 4, and that this coordinate is 2, 1. Now the distances have to be the same. So there's a lot of math I could do to solve this analytically, or I can think smarter, not harder. What do I have to do to go from 1 to 2? Add one more. How do I go from 4 to 1? Okay, great. If we finish that pattern, what would be the numbers here for Y? What did we do to go from 1 to 2? 1. So what do I do again? Plus 1, which means this number is 3. And what did I do to go from 4 to 1? And so what am I going to do again? So 1 minus 3, it'll end up being -2, actually. But we're on the right track, which means that this is the coordinates of my endpoint. So what we did is we looked at the pattern of numbers. If we know the midpoint is between it, we know it has to keep going in the same direction for the same amount. That's a perfect slope if you think about slopes. Same direction for the same amount. So we just used that idea of slope, which is an algebra concept, we'll get to it in geometry later, and created this other endpoint using that pattern. So if you want to write a note to yourself on this so that when you look back at it, you're like, what? So we say find the pattern. Then use the pattern. That's what we did on this problem. We found the pattern, and then we used the pattern. When you've got that written down, flip your paper over so I know you're ready to move on. So if we start on this proof like we did last time, the thing that it starts with is called the given. That means we know this to be true because they told us it already. So my first statement is proven by something called the given. That's essentially always going to be your starting argument, is that the first thing that you were told was given to you. It's the prompt of the problem. What we want to prove is that AB is equal to BC when B is the midpoint. So if we have segment AB and segment BC, we also then know that B is the midpoint. Now, don't overthink this, but what does it mean for something to be the midpoint? They're in the middle, right? It cuts it exactly in half, creating 2 equal segments. So we know that since it cuts it in the middle, it creates this next argument. Do we remember what this symbol means right here? The equals with the little squiggly line on top? We talked about this last time. What did the equals with the tilde? Starts with a C. Starts with a C-O-N. G. So because that we know it's a midpoint, I skipped a step. We said it out loud. We said that because we can put them in the middle there and the little tick marks, that the definition of midpoint, like Jordan said, is in the middle, which means it makes congruent segments. And since we know they're congruent, that definition tells me that they are equal. So we've proven that since B is the midpoint of segment AC, Since it's the midpoint, it creates congruent segments. And congruent segments mean that their lengths are equal. So that's how we argue from the given to the final proof. A new vocabulary word for us today. It goes along with midpoint. It's called a segment bisector. So let's highlight that word because that's going to be a new one for us. Segment bisector. A segment bisector is a point, line, ray, segment, or plane that bisects a segment at its midpoint. Okay, we used to call this intersecting. So these two lines are intersecting. The ray is intersecting. The segment is intersecting. And that works, but it doesn't tell you exactly where it's intersecting. When we switch to use the word bisects instead of intersects, we mean that it bisects or cuts it directly in the middle. So it's more specific about where it is touching it or cutting it. So if you notice, we have a segment bisector or a line bisecting the segment because again, it creates two equal pieces on either side. This could be a ray bisecting it as long as it cuts it in the middle at the midpoint. It could even just be a segment that cuts it right at the middle. As long as the intersecting line, point, segment, ray, or plane cuts the segment into two equal pieces, to see the tick marks, then it is called a segment bisector. We don't just say it's intersecting anymore, we specify that it's bisecting. So if we use this idea, we're going to be able to apply it to measure different segments. Number 7 says VW is shown below. It wants us first to identify the segment bisector. Okay, if we look at this image, we have two tick marks here and here. Those tick marks mean that those are equal in length or congruent segments. So what is in the middle of these two congruent segments? Don't overthink it. What's in the middle? M. What is M though? Is it a point, line, plane, ray, segment? It's a point. So we say the segment bisector is point M. Since we know it cuts it in the middle, we also know that the two sides are equal to each other. So the question here that says, what is the length of VM, is asking for this length, VM. How can we figure out that length? Say again? If we had values, we could totally use the distance formula. If we had coordinates, I love that idea. We weren't given coordinate values though. What were we given above the little image? Some math, an expression. So if we think back to our segment addition postulate that we learned about last time, what do we know about those two things, the blue and the green? We will put it in a formula. Very good. So this is going to be like the ones we did last time. However, now that we know they are equal because of the little tick marks, what we can do is we can just say that the blue is exactly equal to the green. And we know this because we know that VM, the length of VM, is equal to the length of MW. Since it's a midpoint, cuts it in the middle. Okay, if we wanted to solve this equation for x, I know I kind of wrote them out of order. In fact, don't erase yours. I'm going to rewrite mine in the correct order just so that the notes look nice. VM equal to MW, and we had 4x minus 1 equal to 3x plus 3. How would we start solving for x? We practiced this when we went over some homework questions today. What would I do to solve for x? Algebra, yeah, some general algebra. We need to start doing inverse operations and combining like terms to get x by itself. The first thing we'd do is subtract 3x from both sides because we want all of the x terms on the left. This would become x minus 1 equal to positive 3. Because 4 minus 3 is 1. I'm making the 1 invisible. If you want to show the 1, you can. We would add 1 to both sides so that we get x is equal to 4. Huzzah, we're done, right? No, because what's the actual question? I know I went a little fast, so you're still all writing. Once you get it written down, read back the question on part B. What is the actual question here? VM. Well, VM is the blue stuff. So if I wanted to figure out the length of VM, all I would do is take the blue thing and plug what in for x? 4. 4 times 4 is 16. 16 minus 1, 15. So we would say that the length of VM is 15. I don't know why it's not letting me write. Oh my goodness. There we go. Okay, I'm going to get you halfway through problem number 8, and then it's going to be yours to try. It says RS is shown below. What is the name of the segment bisector here? What cuts it in half? N is a what? A line. So we would say this time it's not a point, it's line N. It does meet at point M, but remember capital letters mean points, lowercase letters mean lines. So we know again, because this bisects it, cuts it in the middle, the tick marks tell me that, what can we do with these two values to be able to find the full length RS? We know R to M is equal to 4x plus 3, and M to S is equal to 6x minus 12. So if we wanted to use that information to find all of this RS, we're going to do it very similar to what we just did in solving for x, but then apply it differently. Okay, I'll help you set this up, and then I'm going to let you do the algebra so you can practice. We would say that RM is equal to MS, or that 4x plus 3 is equal to 6x minus 12. I'm going to leave you here, and I want you to do the algebra and then apply it to the geometry to get me my full answer. I'll give you a lot of time on this one. I'm going to start working it silently on the board in case you're stuck. How'd we do on finding x? I assumed you liked the decimal version, so I gave you the decimal version even though I liked the fraction. Okay, hopefully we could get there, but now we have to go back to doing some geometry. What are we doing with this number 7.5? What's the actual question? What length am I finding? Blue, green, or purple? Purple, which means I need both segments, the blue and the green, to create the purple. We would say that RS would be equal to the blue part and the green part. Why did I put these parentheses and leave them empty though when I did this? What should go in that parentheses? 7.5. That's what we got for my x, so we just need to fill it in here and here. Now that's a calculator question because I don't want to do decimals by hand, so go ahead and type all of that in. 4, open parentheses, 7.5, close parentheses, plus 3, plus 6, open parentheses, 7.5, close, minus 12. All in one fell swoop with parentheses and everything. What did we get? 66. Nice. So the distance RS, or this line segment RS, is 66 units long. That's its length. Oh, all this algebra. We're still going to be practicing all of those skills all year long. Our last little bit right here, and I'll pull it back to this part if you needed to still write down, but I think most of us are there, is called fractional distance. And this can either be really complicated or really simple depending on how you think. Fractional distance is just talking about parts of an entire distance. So for example, part A says find x, so find a point on the value from A to F, which is A to F, from here to here, that is 1/6 of the distance from A to F. Okay, this is a flat number line, which means we can just count. It's really, really simple. If we count from A to F, how far does it take us? How long does it take us to get from A to F? Oh, no. So I guess that was unclear. When we're like doing this number, how many loops does it take for me to get from A to F? 13. Okay. Wait, I think we counted wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Should be 12. Don't count until you move. Okay. So it takes me 12 jumps to go from A to F. I only want to go 1/6 of that distance. So what we would do is we say there was 12 steps to get from A to F. We want to divide that by 6. Why 6? It's the 6th distance. Okay, what is 12 divided by 6? 2. That means every 2 steps, I'm going to create a fractional distance. So I start at A, I jump 1, 2, I put a bar. 1, 2, I put a bar. 1, 2, put a bar. 1, 2, 1, 2, and we made it to F. I have partitioned the segment AF into 6 equal segments. I chopped it into 6. We want to find X, so that is only one of those 6 distances away. So if I only go one of those partitions, what number am I at? -5. So we say point X is at -5. What if, instead of saying find X on AF that is 1/6 of the distance from A to F, what if I said that is 2/6 of the distance? Instead of jumping just one of these partitions away, since I said 2/6, how many partitions would you jump? 2. You would have been here at -3. If I said 5/6, what number would you be at if I wanted 5/6? 1, 2, 3, 4, 5. So you count the number of partitions by the denominator number, and then you jump the number that's in the numerator. Let's try another one. We're going to partition another interval. This one says find Y on BE. So this time BE. We're not going from A, we're going from B to E. We want to know something that is 3/4 of the distance from B to E. Okay, first of all, how long is B to E? 1, 2, 3, 4, 5, 6, 7, 8. So we know it's 8 units long, and we want to partition it by how many partitions? How do I know 4 again? Where am I getting the 4 from? The 3/4, the denominator number. Okay, what is 8 divided by 4? 2. So that means, again, every 2 units, I'm going to be creating a partition. So we have 1, 2. 1, 2, 1, 2, 1, 2. I made it to E. There are my 4 partitions. But the question here says find point Y so that it's 3 of those 4 away. What number is Y at? So if we want to jump 3 of them, 1, 2, 3. What number is it at? 0. So we have to create these additional partitions for the length of the segment and then count up those number of jumps. It's a weird thing to partition it, but if you think of it like old school fractions when you broke things into blocks and folded papers into thirds or fourths, that's kind of what we're doing. We are partitioning the line segment or the line.